Domain and range of functions. Hello, everyone. Lesson 4, page 13. So we are right up here because functions convert values of inputs into values of outputs. So we've seen a lot about inputs and outputs, plugging them into the formulas, composition of functions. The next, we talk about sets that represent these inputs and outputs. The set of the input in an output is called the domain. Then the set of the outputs is called the range. So the domain are your input or your x values. The outputs, the range, are your y values. So consider the function, exercise 1, that has as its input the month of the year and as its outputs the number of days in each month. In this case, the number of days in a function is a function of the month of the year. Assume the function is restricted to non-leap years. So they want us to write in roster form the set that represents the domain's function. So what you would have to do is you would have to write it out. And you would write out January, February, okay, on and on and on, all the way to December. Okay? So if it wants it written out, that's what you have to do. Okay, so like on a test, a quiz, the readings exam, you'd have to write everything out. And then write in roster form the set that represents the function's range. So in February, we have 28 days. And in January, 31. April, we have 30. Okay, maybe you can ask me in class how to figure out there's a little trick that if you ever get into accounting or some other business, you might have to know how many days are in each month. Okay, so remind me to do that in class if I forget. Now, exercise 2, we are using a formula. So we have an equation, f of n equals 2n plus 1. The domain is the set 1, 3, 5. So the domain is usually on the left. Those are your input values. Show the domain and range. So we have the domain, 1, 3, 5. The range would be the output. So we need to take and put the 1, the 3, and the 5 in for the n. 2 times 1, which is 2, plus 1 is 3. So there's the output. When I put 3 in, I get 7. When I put 5 in, so 5 times 2, 10 plus 1, 11. So that is the range. So when I input 3, I get the 7. When I input 5, I get 11. Okay? And that's showing the domain and range, and that's it. Perfect. In exercise 3, the function y equals g of x is completely defined by the graph shown. And then we have the following questions. So determine the minimum and maximum x values. So we're looking at x values. So a good way that you can do this is you can kind of box this in. Okay? Box it in. Okay? So that you have the entire graph included in the box. And then it's very easy to see. So here is my smallest x. This is my largest x. So find the y-axis. So the minimum x value is negative 3. The maximum is 1, 2, 3, 4, 5 is 6. So determine the minimum and maximum x values represented on this graph. So it's negative 3 and 6. Determine the minimum and maximum y. So here we are again. This is the max. This is the min because we boxed it in. It's nice and easy to tell. So you count 1, 2, 3, 4, 5. So I have a negative 5 and then up to 4. So that's the min and max. Now, we want to state the domain and range of this function using set builder notation. So the set builder notation, it's very key that you identify which is which. So we have the domain. Set builder notation says x such that we have negative 3 less than or equal to x less than or equal to 6. Okay, that just means that x is going to be between negative 3 and 6. For your range, it is your y value such that the smallest is negative 5, less than or equal to y, less than or equal to 4. Because they're all inclusive. How do you know they're all inclusive? Because of these circles here. Okay, are filled in. If they were open, then we would not have an equal sign underneath the inequality. Okay? Some functions, well, here's a multiple choice. Okay? The function is graphed on the grid. Which of the following represents its domain and range in interval notation? So the previous problem was a snapshot. All right, it did not have arrows at the end, so it had a starting point and an ending point. With this one, I have arrows. So that means it goes on forever. So when I'm looking at the domain, it's all the possible x values. So all these possible x values. And since this goes on in both directions forever, okay, my x values, my domain, is going to be negative infinity to infinity. Because every single value can be a part of the domain. And now, none of these have the negative infinity to infinity. So by process elimination, it is choice 3. But to prove it, you want to find the range. So the range are your y values. So my y values start down here and go up to infinity. Okay, positive infinity. And this starts at 1, 2, 3, 4 at negative 4. So that's why it's choice 3, because that meets the qualification of the domain and the range. Most functions aside, okay, so if it's all real numbers, the symbol is an R. I will write it, I'll put it over here. I will write it like that. That means all real numbers for me. Now, we look at exercise 5, we have a fraction. F of x equals 2x plus 1 over x minus 4. Now, you have to be very careful when you have fractions, because you always have to consider the denominator. Because if I have a denominator of 0, that means that it is undefined. So if I put this in my calculator, let me just show you something real quick. So if I put the 2x plus 1 over x minus 4 in my calculator, and I hit enter and I graph it, you can see that it is not a continuous graph. This side here kind of goes down, and this one's coming from positive infinity and going towards a number, or continually going towards negative infinity. Now, what happens is, at 4, you will see it's undefined. So if you put it in your graph, you will be able to tell. We call that an asymptote. So we would have an asymptote where x equals 4, because you will have no values. And if you want to see more of the graph, you would just zoom out. All right, so that's why when you look at the table, it says error. Or what did ours say? Ours said undefined. Now, value f of 1, f of 6 at the table. So f of 1 is just negative 1. F of 6 is 6.5. Why does the calculator give an error? I just told you why. It's undefined. Are there any values except x equals 4 that are not in the domain? No. Okay, all other values are in the domain, because that 4 is the only place where it's undefined. And the last example, which of the following values x would not be in the domain? So we saw, I don't know if I'm in your way here or not. We saw with the fractions that you had to worry about the denominator. But with radicals, you cannot have a negative underneath the radical. So what would have to happen is your x plus 4 has to be greater than or equal to 0, because I can have a 0. So I can have square root of 0, which is 0. My domain is going to be x is greater than or equal to negative 4. Those are all the values that fall in the domain. And if you were to put this on a number line, here's your negative 4. Okay, color it in because it's inclusive. And it goes like that. So 0 is here, 5 is here, negative 3 is here, negative 8 is there. So which of the following would not be in the domain? And it is choice 4. Okay, x equals negative 8. To show that on the calculator, and I'm going to show plugging it in. Oh, I'm in the way again. So I have to do your square root, and then it's x plus 4, x plus 4, enter, go to the table, Control T, and you can clearly see that my values, 0, 5, and negative 3 all have values, and then when I get to negative 8, there's an error. Okay? So that's another way you can do it, or you can even use the such that. So That's it for lesson 4. Remember, we got a quiz coming up on Thursday. Remind your parents that I'm at open house Wednesday, the 18th. If any of them want to stop by, if they're here with a younger brother or sister, or if they just want to stop in or whatever on Wednesday at 6:30, I'll be here. So, yeah, until tomorrow. All right, I'll see ya.